Let's discuss the type of kernels in SVM. So full form is a support vector mission. SVM operates with the 4 types of kernels. Let's start with the first one. Is the basics as a kernel. It's a linear kernel. Linear kernel is straightforward. It's just a dot product between the futures. Sorry, it's a dot product between the futures of the input data like x and y values. It is often used like a classification. So it's binary classification tasks such as identification of spam or not spam. The example I show in the example. I import some sklearn, the feature extraction, the text, the pre-processing has a df idf vectors and SVMs, sklearn SVM import SVC support vector, and then model, the train test split, the import train and matrices classification report classifications, and then we have the data sets of the email. So it's it's a very small samples like one or 3-4 samples, and then with the labels like we have the data of emails, so very few samples, 1 or 2 or 3, and then we have the labels and 1 0 and 1 0. So if 1 is represents the spam and 0 is not spam, we initialize the vectorization df idf vectors, and then x equal to it's converting the transformations of the emails into the df idf vectors, and y is equal to labels, we take as labels, and using this trying plus fit function, we divided the x and y values using the 4 variables x train and x text, y train and y test, and using some random functions, it's random state is 42, and fit the model as we have, it's initializing the SVS kernels, initializing the kernel and fit the kernel x train and y train, and protecting the kernels, the printing, and then we trying the model and protect the models like we'll show in the example. Let's take some time. Okay, this is a precision recall accuracy support. It's a 10101111. This is got the values like if you have the heavy, like it's a huge values, that's the model works very well. I don't have such more have the huge values, that's why it's the values are like 0 1 something. It's not give the accurate score of precision recall and zeros. That's why it's not going not get output, like it's not accuracy. And then we have the under kernel, like the second type of kernel is a polynomial kernel, which is used the non-linear data. It maps the input futures into the higher dimensions, spaces into the polynomial functions of specified degrees. Like in this example we taken the digits, log digits, we taken as a which contains the handwriting digits recognition data, and then we initialization the values x and y in the digital data and digital target, and then we have to split the data in the using the train test split in the function, and initialization the kernel has a polynomial, and the degree of degree is equal to 3, and the gamma is a scale. How can you can identify the kernels the degrees? Basically degree 1 or 2 is a soft, often the significant the simple patterns, while the degree 3 is used in the more complex relationships, but the degree above 3 are rarely used because it's a highly dimensions increasing computation complexity. But the degree 3 is highest. Most of the cases we didn't use any real-time scenarios like 1 or 2. So most of the times the polynomials is 3, and then the gamma is a scale. There's 2 types of the gammas. The default is auto, and then you can set the scale. The gamma is one of the most important thing. I show in the formula as it's a gamma. Gamma decides specify. You can also specify 0, 0.1, 2, or 10. Depends upon your problems, but you can also use the finding some for loop, which a gamma model works very well, like which gamma values working well. Gamma determines the gamma determines the curvature of the decision boundaries. That's why you need to set the gamma parameter. Then we train the data like then we fit the data and predicting the extract, and the accuracy is 0.991. It's the train model, the value of the accuracy we around says 98%, sorry is around the 99%. Like this is already clean data, that's why. Next let's discuss about the RBF kernels. In this example, taking the subset of the MNIST datasets, which contains the handwriting images, that contains the data contains the 6,000 images, sorry, it's the data contains 60,000 images, but we selected only the 10,000 for sample or for simplifications. Then input values and x and y, sorry, input is x contains the features and y contains the output values as the labels. For this task, as a y labels is a converting it to the binary, as a y is equal 0 or 1, and then the dataset into the splits using the time test split, and then we RBF kernels, the kernel is applied. The gamma parameter is a crucial in the hyperparameter in RBF. It determines how far its single training examples influenced by the decision boundaries. A smaller gamma produce the smooth decision boundaries, which is a larger gamma make decisions fit the closer to the dataset. It's taken, we have the 0.1 and the train the model and the predict, train the model and predict. It takes a few seconds. It's a higher dimension data set. The RBF kernels is efficient with the non-linear data as it maps the data into the higher dimensions and to separate with the decision boundaries. And basically, it's using the formula as exponent, and the gamma is the modulus of x minus 1 whole square. That's why it deals with the higher dimension values. This is the formula I mentioned. X and y. This is the formula. It takes 20,000. Let's increase the RAM. That's nice. It's got 0.89% of the accuracy, but that's no, okay, that's fine. This accuracy is very good. Either it's got it's not overfitting or anything, it's but its values are good. And then we have the sigmoid kernel is less commonly used in the SVMs, but similarly sigmoid is active, functions in the neural networks. The datasets, this datasets will contains some reviews, as like as a positive and negative reviews, and then we convert it to TF-ID effectors and the train the model, and using the gamma as a scale, and using the kernel and the predictor models. That's it. The Sigmoid kernel is not widely used as a linear and RBF or the polynomial kernels, but it is not well in certain use cases when they combine with the neural networks. I show this is the gamma virtual role that defines the decision boundaries for the SVMs, and this is a matplotlib define the gamma. I show in the example the gamma 0.1 is a product has a very low smooth boundaries with fewer outputs, but yeah, the gamma 1 it contains slightly more refined the boundaries, capturing the more details of the data, and the gamma 10 it's a lead to tight boundary, but this may causes overfitting. And the gamma 2 or the highest, this is not recommended. As a result, I excuse the overfit of the poor generations. In the most cases, we take in the gamma 0.1 or the 1 or the 10 is has preferred. This is and has the provide the balance between the model and the complexity of the performance. These are the kernels we used.